mic's recording. Use the mic, it's recording. Use the mic. Look, hear you.
Hear me? Yes. I'm Mrs. Sanders. I'm one of the third grade math teachers, and what we're going to start talking about tonight are the different multiplication strategies that we've been teaching your children. As Ms. Griffin mentioned earlier, it looks totally different than how we learned it, even me. I'm not that far removed, but you know. So we just wanted to put a couple of examples up here. The whole point of multiplication is for them to understand why they're doing what they're doing. It's not enough to just say, I know that 3 times 7 is 21. Okay, how did you get that answer? We have 8 mathematical practices that we have to instill in our students every single day. And one of those practices is making sure they can justify their reasoning and explain their answers. So in order to do that, when we have a problem like 3 times 7, I'm going to skip down here for just a second. We taught all of our students that the multiplication sign means 3 things: rows of, jumps of, and groups of. So if we think about it that way, it's not just 3 times 7. It's 3 groups of 7, 3 rows of 7, or 3 jumps of 7. Are you confused yet? You're not lost in the sauce yet, right? Okay. So one of the first strategies that we talked about is an array. And with an array, that's when we use our word form of 3 rows of 7. So here we can use dots, they can use hearts, they can use smiley faces, whatever they need to use to build that array, it does not matter. As long as they have 3 rows with 7 dots in each row. Still with me? Okay, so we have 3 rows here, 7 dots in each row. Oh yes, and they all have to be lined up nice and neat, okay? So I tried to make this as neat as possible, so please forgive me if it's not. An array is one strategy that they can use, but over here we have an area model. An area model looks just like an array. The only difference between an area model and an array is that an area model has no spaces. It's no gaps, no spaces, and they're usually made with squares. So that's why the area model looks like this. And we tend to tell our students to make sure that they number their rows and their columns as another way to self-check their problems. Because if you number your rows and your columns, you can see that you have 3 rows with 7 in each row. Okay? One of the ones that's the most confusing sometimes is a number line. We did not use number lines like that when I was in school. Okay? So how many of you are like, what in the world is this on this paper? Right? Okay. That's when we talk about our word form of 3 jumps of 7. So, if you look at the number line, all of our number lines always start with a 0. And we normally tell the student that when you look at your equation and it says you have 3 jumps, go ahead and make your jumps on your number line so you know that's how many jumps that you're going to make to get to your answer. And the answer to a multiplication problem is called the product. Okay, using that math vocabulary is also very important. So, if we have our 3 jumps here, from 0 to 7, you went plus 7 numbers. You went 7 numbers from 0 to 7, so that's 1 jump of 7. The second jump, that's 2 jumps of 7. The third jump, 3 jumps of 7. And we also self-check by labeling each jump to make sure you're adding +7 each jump. So in the end, that's 3 jumps of 7, which equals 21. Still with me? All right.
Okay, another thing we talked about, since 3 times 7, again, is 3 groups of 7, right here, we show the children how this is also 3 groups of 7. So whatever our story is, and we try to have a story, a real world example, something that's in all of our everyday lives for every problem that we do, every math problem that we do in class. We try to relate it to something real, whether it's cookies or brownies or cupcakes or stickers or football or Barbies or whatever that they want to talk about. So again, and since we've got our 3 7s, it's 3 7s, and it's pretty much just repeated over and over and over again. Our story problem here that goes with 3 groups of 7, David had 3 baskets with 7 apples in what class? Each, right. He can't just have 3 baskets with 7 apples, because that's 3 baskets and 7 apples. But we have to be sure that we can visualize that there are 3 baskets and that each basket has the what? The same. And that they're all what? They're all equal. And that's the whole point of multiplying, is that it's repeating over and over and over again. And that's why when we were all growing up, we learned it just as a fact, and now we're trying to explain to them, get them to more understand it. So it's not just 3 times 7 is 21, but it's 3 groups of 7. So how many baskets does he have, what? In all. I'm sorry, how many apples does he have in all? Not baskets. Of course, he has 3 baskets. And then we would say he has 21 apples in all, or he has a what of 21? Good. Okay. And then this is another way. We call this a pictorial, or just equal groups. They can draw. Again, you're going to start with your three groups, and right here we have 3 groups shown by what? 3 circles. You could draw 3 boxes, you could draw the 3 baskets. As detailed as you want to do it, but eventually we want to get to the point of becoming a little faster, and if you need to draw a picture, that's awesome. Eventually, we want to get at the point of remembering it. But right now what we're trying to see, this helps me visualize it a little bit better. I see 3 whats? I see my 3 baskets, and I see in those 3 baskets the 7 apples, right? So then you can put your 7 dots, 7 X's, 7 hearts, 7 smiling faces. You can put 7 apples in there, whatever you want to put in there, as long as they're all what? Equal, and they're all the same thing. So I can't put smiley faces in this one, and apples in this one, and cookies in this one. It's got to be all the same. And there's again, all this is just the same thing in different ways. There's my 7 plus 7 plus 7. There is our 3 rows of 7, 3 columns, or 3 rows with 7 columns, and there's our 3 jumps of 7. So, I think that.
Another reason why we do all of this is because all of it matches this problem. They have to understand why 3 times 7 looks like this. 3 times 7 does not look the same as 7 times 3. 3 times 7 is 3 groups of 7. 7 times 3 is 7 groups of 3. So even though we learned it as, okay, it doesn't matter which way you put it, when they're drawing their work and showing their work, it has to match the equation. Because when they get to that test, it's going to have to match or they're going to get it wrong.
And then I know that most of us growing up, and most of you as parents, or most all of us as parents, we hope and we expect our children to memorize these facts. That is our goal as well by the end of the year, though. The standard, the Common Core standard, and for several years now the standards say, and what we expect the children to do is to memorize and to be fluent. They use the word fluent by the end of the year. Now that doesn't mean we're going to start memorizing in June. you can go ahead and start working with your children on working on those facts. Pick one set, like 3s or 2s or 5s, and work on them. But right now, what we're working on is just what it means, because the Common Core, the past test is not going to say what's 3 times 7. It's going to say this right here, and we need for them to understand what to do. So. All right, we have a little activity for y'all to do. We have some quiet dice and some little papers that your children have seen probably a million times, and you've probably seen some of them too. And we brought some pencils. We put tables in here, but thank goodness, we have many more of you than we do tables. So if you want to move to a table, you can, or if you just want to put sit between a chair or whatever, and you can roll a dice or a die, and the children probably know what to do. There's a space on there for each one of these, okay? And if you have any questions, just raise your hand and we'll come around and help you out. And then we're gonna play this for a few minutes, and then we're gonna come back and do part 2.
Just in case you have a question, the word linear means number line. That's the same thing as a number line up here. All right?
Raise your hand if you need another paper or a dice.
We're going to try to explain it to you. The children don't have to know that word. We we use different words in the classroom. We just breaking apart numbers to make multiplying easier. Doesn't that sound better? Distributed property. Okay. Okay. We tried to find some things that would explain it, but we're also going to work one out. It says the distributive property of multiplication may also be called the spread it out property. But we're saying break it apart, make it easier, make it where I can multiply. For instance, it says the 6 was spread out as 4 plus 2. Maybe I don't know 5 times 6. That's okay. There's another way for me. But I do know that if I break apart the 6, 4 plus 2 makes 6, so I'm still going to multiply 5 times 6. I just made it easier for me. After you break the 6 apart, you have to still multiply it 5 times both of the numbers that created the 6. 5 times 4, 20. Then I'm going to add it to 5 times 2, which is 10, 30. It's still 5 times 6 is 30, isn't it? We just broke it all the way apart into baby points. Okay. Now we're going to show you. Now that smarter balance, some of those assessments, the children may get it like this, but those same strategies that they use for those multiple representations of multiplication, the first thing they're going to do, let me come over here first. Whenever they see it this way, the first thing I'm going to do, get ready to put this down. Count my rows. How many rows do I have? Help me.
1, 2, 3, 4, 5, 6, 7.
I have 7 rows. So I'm going to write 7 down. Let's see how many of these pretend they're shambles. Okay, because I couldn't draw. Okay, in each row I have how many?
1, 2, 3, 4, 5.
So right now I have 7 groups of 5. In order to find my number, I don't have to count 1, 2, 3, 4, 5, 6. It'll take forever. At the first row, and I know that some of you all probably have seen your children doing this, and you wonder what in the world are they doing. In the first row, I have 1, 2, 3, 4, 5. So I'm going to write 5 on the outside so I can find my answer still another easier way. So when I get to the next line, will I put 5 students or will I put 10? Got it. I'm going on to the next row.
15. 35.
So that means that 7 times 5 is 35. And all I did was skip count multiples of 5. I wish they would have did this when I was in school. Now, even though I used skip counting in multiples of 5 to find out what the product was, 7 groups of 5 is 35. Then I came to class on Monday, and these 3rd grade teachers tried to make me break it apart. Now I'm looking at this number, and I have a visual representation to help me understand what 7 times 5 is. I have a visual. I know what it is, but I don't know how to break it apart. Let's see. Just Bryson. How can I break that apart? Can you help me? How can I break these numbers apart to make it easier for me to multiply? She said I could draw. Listen, we don't have a smart board in here. This PowerPoint, I can't write on it. Let's see. She said 1, 2, 3, 4. Can I? 5. I have a line here. Yes. She's gonna do it on that. So I just broke it apart. I have 1, 2, 3, 4, 5 groups of 5. Can you write that out to the side, beside that one? 5 groups of 5, that's 5 times 5. But I have 2 lines, 2 rows still left. 1, 2, 2 groups of 5. How about we just broke apart that 7? 5 plus 2 is 7, isn't it? Just broke apart. Now, is that a little bit easier to multiply than that big number, that 7? So now, I've already skip counted. I already have my answer. 5 groups of 7, 5 groups of 5, or 5 rows of 5 is 25. Now I have 2 rows of 5. 2 times 5 is 10. Now Miss Bryson's going to take both of those products, and she's going to bring them down here and add them up. My goodness, it's still 35. Is that? It's just another way. It's an alternative. Even if your child can multiply, this is another way for them to conceptually understand what they're multiplying. They're understanding the numbers. Do we have any questions? And we practice this during our whole math time. And then they come home, and I tell them, don't try to trick your parents. If you need more help, more examples, just let us know. But we practice the whole entire math time. Many examples.
Okay. So that we can get you guys out of here on time and get to the pizza, we have a little handout for you about the properties that we are teaching the students right now. So please make sure you grab one on the way out. Also, if we can, I know you signed in the front, but we have tickets that we want to give to each student tonight. But in order for them to get their tickets, you need to sign this sheet so that we know which 3rd graders came tonight. They're going to make a drawing from this sheet, and whoever they pick will get a prize, and they'll give it to them at school later on, okay? So please make sure you sign the sheet. We'll be at the door with this clipboard. Please make sure you sign it, and then you can get some tickets for your students, all right? Thank you so much, and we appreciate you coming out.